Hi guys, welcome to tutorial 10, question 3. Let's do this. As always, I'm going to put the question right over here, pause the video, read it over, attempt it yourself, and then we'll go through it together. Now, as we're reading the question, it says prove that the DFA in exercise 1 is minimal. Now, if you haven't seen exercise 1 or even exercise 2, I really recommend you watching that too. I'm going to put them right here on the YouTube thingy that says I, and if you can't see that, I'm going to put it in the description below. Again, Oh, I thought I started recording. Oh my god, it's 5 a.m. and I'm going crazy. But I'll put them obviously up there and watch them. It's very beneficial. I think it's very important. But then I'm going to assume you've already seen them. I'm going to keep going forward from this moment on. Now, our DFA, I'm going to put it right over here, has 4 states. We want to prove that the 4th state is minimal by, using the pigeonhole principle. Now, the pigeonhole principle is very simple. If I have 4 boxes, right, and I have 5 pigeons, right, if I place pigeons into the boxes, there has to exist at least one box that has 2 pigeons in it. Putting it another way, if the number of pigeons is m and the number of boxes is n, if m is bigger than n, that means there's 2 of them in the box, in a way. And it's the same thing here. Because there's 4 states, right? I'm gonna choose 4 strings where each one of these is going to lead to a contradiction. And you're gonna see what I mean by that. Here are the 4 strings I've chosen. I chose 0, I chose 1, I've chosen 2, and I've chosen 2 zeros back to back. Now, 0 and 1, choosing 2 of those, right? 2 of the pigeons. 0 and 1 are distinguished by the suffix 2. What does that mean? All right. If I grab 0 and if I add a 2 to it, it's going to become 02. Is 02 an element of this language? No, it's not. 20 is, but not 02. Now, if I put the 0 away and I put 12, is that part of L? Yes, there is no bad zeros here, so yes, that's going to work out. Now, if I grab, 0 and 2 in the 4 strings, I grab 0 and then 2, right? 0 and 2 are distinguished by the suffix 0. Again, what does that mean? If I grab 0 and I put a 0 here because it's distinguished by 0, 0, 0 is not part of the list because that's a bad 0, right? But if I grab 2 and replace it with the first 0, it's going to be 2, 0. Is 2, 0 part of this language? Yes, because it's being preceded by a 2. The 0 is being preceded by a 2, so of course it's going to be a part of the language. So, they are distinguished by the suffix 0. Now I'm going to grab 0 and double 0, right? And, it begs the question, what is this combo distinguished by? And that's the suffix 1. If I grab 0 and I grab 1 and I put 1 over here, 0, 1, is that a part of this language? Yes, it is. There's no issues over here, right? But is 0, 0 and 1 part of this language? No, that's a bad 0, right? So that's not followed by a 1 but preceded by a 2. The first 0, I mean. So that's not part of the language. And then grabbing 1 and 2, again, same idea. What is this distinguished by? And it's distinguished by the suffix 0. If I grab 1 and 0, right, that's not part of the language. But if I grab 2 and 0, that is part of the language. And then if I grab 1 and 0, 0, and I compare them, again, the suffix for this is going to be actually epsilon, right? Because 1 is part of the language, but double 0 is not part of the language. Similar to similar reasons I've explained before, double 0 is not, and we've used epsilon as a suffix here between the two. And finally, if I grab 2 and double 0, right, and, try to compare them, it's the same thing. We're going to see that the suffix epsilon, is the one that distinguishes both. 2 is a part of the list because there's no zeros in sight, so who cares? But double 0 is not part of the list because it doesn't satisfy the rules that it needs to, right? So, yeah. I don't know if you saw what I did, but basically I grabbed these 4 strings, I compared each one with every other possible one that it could be compared to, and I was like, you know what? Can there be a distinction made or not? And I saw that every single one of these pigeons, not two of them fits in the same box. At all times, only one of the pigeons fit in the box, not both of them. If both of them worked and both of them were part of the language, then yes, that would show that that is not minimal. But in this scenario, because every single one took its own box, it is the four. Four is the number of minimal states that this DFA could have, and that's pretty much it. And before I wrap up, I do want to, clarify something so that you don't think I'm just telling you this and, that's it, that's the answer. Try yourself. Instead of 4 strings, try 5 strings. It should fail. You know what I mean? Because again, by pigeon theory, if 4 of them, all of them are being distinguished, right? If you give it 5 strings and you keep comparing all these 5 with each other, I promise you, 2 of them, like 2 of them are not going to be distinguished from each other, and by a certain suffix, and both of them are either going to be an element of the language. And give that a try yourself. And you should see how that works out. Different examples, or this example, but definitely check that out yourself. That'll be all for this question. I'll see you guys in other videos.